In this problem, a pipe which carries an oil of specific gravity 0.9, specific gravity is given as S, that is 0.9, okay, which is at velocity 3 meters at two sections are there here. So we'll take this section, the first section over here, which is of diameter, we'll take this as section 1 and this is section 2. So here in the section 1, the diameter is at this particular section is 25 centimeter, so that is equal to 0.25 meter. Okay, now the area of the cross section area of section 1 will be pi by 4 d square. So here the area will be of this section will be pi by 4 into 0.25 square. So that will be equal to 0.049 meter square. Okay, now the velocity at this particular section, at the first section as given in this problem, is 3 meter per second. Okay, now the discharge, now the discharge is what we have to calculate. So discharge will be nothing but area into velocity. So that is, so it is 0.147 meter cube per second. So this is the discharge from the section 1. Now in the section 2, we have to find what the given data is, that the diameter is 20 centimeter. So that is equal to 0.2 meter. Now the area, the cross section area A2 is nothing but pi by 4 into 0.2 square. So that is 0.0314 meter square. Okay, so we don't know the velocity here, the V2 we don't know. If we don't know that, neither we know the discharge here. So the question that been asked is you have to find the velocity as well as mass rate of flow of the oil. Now by applying continuity equation for the section 1 and 2, what we get here is A1 V1 is equal to A2 V2. So this is the continuity equation here. Now what is A1? A1 is nothing but 0.049 into, write it down, 0.049, okay, into V1 is what? 3. A2 is nothing but 0.0314 into the V2. So by calculating this, we get the value of V2. So that is nothing but 4.68 meter per second. Okay, so once we get here this V2, that is 4.68 meter per second, this is the velocity. Now to find out discharge is not what we look for. We have to find the mass flow rate of the oil, the mass rate of the oil. So this is discharge. So how do you find out that is? Mass rate of flow of oil is nothing but it is the mass density into discharge. So what exactly does this means is that mass density is what? Kg per meter cube, and what is discharge is meter cube per second. So cancel it out. So you'll get mass rate flow, that is kg per second. So this is the mass flow rate of the oil. Okay. Now keeping this in mind, the density of oil is nothing but specific gravity of the oil into density of a standard liquid, that is nothing but water. So density of water, so that will be equal to 0.9 into 1000 kg per meter cube. So it will be 900 kg per meter cube. Okay, now the mass rate of flow is nothing but this 900 into the discharge is how much? This is a discharge here, 0.049 into 3. The discharge is 0.147. Okay, so that will be equal to 132.23 kg per second. So this is a mass flow that we